While his mind is still alert, the aging Mr. Jones arranges to have his brain scanned by a cerebroscope, a device which will record the exact pattern of connections of the billions of neurons in his brain. Since the early 18th century, many scientists have felt that the total personality of a human being is encoded in the physical structure of the brain. In recent years, cognitive scientists at universities such as Stanford, Carnegie Mellon, and MIT have dreamed of a day when man may attain immortality by preserving a computerized copy of his neural patterns. In 1936, the mathematician Alonzo Church argued that any computation that can be systematically performed can also be performed by certain universal processes of computation. In the late 40s and 50s, computers that could carry out these processes were first built using electronic circuitry. In principle, any computation, however complex, can be carried out on an electronic digital computer. If the human personality is entirely reducible to brain computations, it follows that a particular human personality, such as that of Mr. Jones, can be duplicated by a suitably programmed computer. This computer could be linked to a robot body, thus allowing Mr. Jones to live again. Insurance against accidental death could be provided by preserving backup copies of the Jones personality in a safe place. In principle, the robot body could be repaired and improved indefinitely, thus giving Mr. Jones the prospect of enjoying ever more powerful bodily forms in an unlimited future. Can a computer program duplicate the essence of human personality? In 1950, the British scientist Alan Turing argued in a famous paper that computers can do this. He maintained that the essence of human personality lies entirely in observable human behavior, and that any behavior that can be systematically observed and described can also be duplicated by a machine. On the basis of this assumption, artificial intelligence researchers tried to write programs duplicating human intellectual functions. They encountered some success in writing programs for mathematical problem solving and games like chess. But it proved impossible to duplicate more basic forms of behavior. These include the processes of pattern recognition in vision and hearing, as well as the capacity for ordinary speech. And thus far, artificial intelligence researchers have no idea how to represent the knowledge that a 3-year-old child has of his mother's kitchen. One impediment in artificial intelligence research has been that existing computers execute one instruction at a time, whereas the brain contains some 100 billion neurons, all working simultaneously. It is hoped, however, that parallel processors will be developed with the ability to mimic the brain by executing many millions of operations at one time. Parallel processors simulating neural networks have already proven useful in various tasks involving pattern recognition. However, there is still the problem of figuring out how to program a vast network of processors to duplicate brain functions. It is here that the idea of scanning the brain comes in. Some scientists speculate that if it is possible to do this accurately and thoroughly, it may be possible to construct an electronic duplicate of the brain. It is hard to say whether or not this will ever be possible. At present, it is certainly little more than a distant dream. But let us suppose that the brain patterns of Mr. Jones have been captured in electronic form. Let us suppose further that Mr. Jones' original behavior is precisely duplicated by his new robot body. We must still ask, is the robot conscious, or is it simply producing Mr. Jones' behavior without conscious awareness? To introduce the idea of consciousness, let us consider a simple machine that prints a message saying, "I see a red light," whenever a red light is shown on it. This machine consists of nothing more than a photocell, an amplifier, and a printer. Therefore, we do not tend to believe that it has the conscious experience of seeing red light, even though it says that it does so. Of course, some philosophers question the very idea of consciousness. The eliminative materialists say that words referring to consciousness cannot be objectively defined, and therefore we should not use such words. They propose that instead of saying, "I feel a pain," it would be more scientific to say, "C fibers are firing." But this simply demonstrates the reality of consciousness, and the fact that whether we can objectively define it or not, we are able to talk about states of consciousness and understand what we mean. The 19th century scientist Thomas H. Huxley accepted consciousness as a reality independent of matter. He described consciousness as an epiphenomenon, a manifestation that is affected by matter but has no effect on matter in turn. The fact that we perceive material things shows that consciousness is affected by matter. Huxley's requirement that consciousness does not affect matter in turn served to prevent it from violating the laws of physics by producing effects not predicted by these laws. If we accept the reality of consciousness, we can ask the question, can a machine be conscious? The philosopher John Searle has thrown interesting light on this question by presenting the following argument. Consider the computer that duplicates the brain activity of Mr. Jones. Suppose that it is conscious, just as Mr. Jones himself would be. The important thing about this computer is its logical structure, which duplicates the logical structure of Mr. Jones' brain. This same logical structure can be embodied in a computer consisting of a large group of people seated at desks. In accordance with certain simple rules, each person receives slips of paper from his neighbors, makes marks on them, and passes them to other neighbors. By setting up the rules properly, this group of people will precisely duplicate all of the operations of the Jones computer. Just as the Jones computer duplicates Mr. Jones' brain, so this group of people collectively duplicates both the Jones computer and Mr. Jones' brain. Does the group of people manifest the consciousness of Mr. Jones? Each individual in the group knows only his own activities of making marks on pieces of paper, and we can suppose that he does not even know the purpose of the group as a whole. Surely the consciousness of Mr. Jones is not present in any of the individuals in the group, but is it present in the group as a whole? It seems most reasonable to suppose that in fact, the only consciousness in the group of people is that of the individuals that make it up. But if this is so, then what can we say about the Jones computer? Shouldn't we conclude that it also lacks consciousness and is simply producing behavior by a mechanical process? Finally, what about Mr. Jones' brain? What special feature does it have that creates the conscious experience of Mr. Jones? Its logical structure as a computer is the same as that of the Jones computer and the group of people. It only differs from them in the way its operations are carried out, by nerve impulses instead of by electrical currents in semiconductors or by the passing of written notes. A nerve cell builds up an electrical potential between its inside and its outside. A nerve impulse involves a localized flow of ions across the cell membrane that neutralizes this electrical potential. As this flow takes place, it triggers a similar flow in adjacent parts of the membrane. Thus, an electrical signal propagates down the length of the cell. From a computational point of view, the important thing is that some kind of signal is sent. The particular mechanism does not matter. The same thing can be said about the switching functions carried out by neural synapses. The theory of the brain as a computer holds that only the logical arrangement of neural interconnections is important in determining human mental functions. We have seen that this logical structure does not account for consciousness. Could it be that consciousness is a product of the particular physiochemical structure of neurons? Actually, there is no more reason to associate consciousness with this cellular machinery than there is to associate it with the amplifier and photocell of the red light machine. As Huxley suggested, consciousness seems to be a real feature of nature that is not understandable in terms of physical structures and processes. It must be postulated as an extra irreducible element in physical systems. The example of electric charge shows that the idea of an irreducible element is not foreign to modern physics. It is reasonable, then, to introduce consciousness as an irreducible element and inquire into its nature. Some thinkers, such as the mathematician Rudi Rücker, suggest that consciousness is comparable to an undifferentiated light that shines through material structures, illuminating them with self-awareness. According to this idea, the one perception I am is common to all material patterns, and the thought I am Robert Smith is simply this I am shining through the particular brain hardware and software of Robert Smith. In a molecule, this I am shines through the array of nuclei and electron orbitals, resulting perhaps in a dim awareness of harmonious molecular vibration. In a neuron, this I am shines through the membranes, microtubules, and other components of the cell, and perhaps produces a dim awareness of growth, metabolism, and nerve impulse activity. Finally, in the brain of Robert Smith as a whole, this I am shines through the total neural system and produces the rich conscious awareness of Robert Smith. But wait, if the brain of Robert Smith is simply a combination of molecules, each of which has some experience of I am, then why isn't the total consciousness of that brain simply the collection of these individual states of molecular consciousness? This is the point of our group computer example. The only consciousness we expect to find in the group is simply the collection of the individual states of consciousness of the group members. To clarify this point, consider this chart showing how theorists of artificial intelligence believe that thoughts and feelings might be represented within a computer. At the lowest level of the chart, we find computer hardware. As we go up the chart, we encounter software on higher and higher levels of abstraction, ranging from the level of machine language up to the level of languages containing symbols that refer directly to thoughts and feelings. All of the higher levels are abstract. Only the level of silicon chips and electrical currents is physically real. Yet our consciousness corresponds to the highest abstract levels and not to the level of physical reality. This is also true of the human brain. Whatever this I am is, it links up with high-order abstract patterns of organization. Instead of shining through matter like ordinary light, it illuminates complex patterns with a unified awareness of their meaning. To illustrate this feature of consciousness, consider a novel. The physical structure of the book consists of ink on paper. But there is also a hierarchy of levels of abstraction, ranging from letters to words, sentences, character portrayals, and finally the plot of the story. Just as a human reader perceives the plot in the pattern of ink on paper, so consciousness picks out high-order patterns in the human brain. One might object that all pattern recognition can be accounted for by brain mechanisms. For example, we can imagine a neural network which triggers the firing of a particular neuron if and only if an image of Robert Smith's grandmother is projected on the retina of his eye. We can call this cell a grandmother cell. Such a system may help account for the behavior of Robert Smith when he recognizes his grandmother. However, the grandmother cell fires neural impulses just like those of any other neuron. Thus, for Robert Smith to be conscious of his grandmother, the I am must respond to complex details of the neural network as a whole. It cannot simply be linked to the grandmother cell. This brings us naturally to the idea that consciousness involves a non-physical entity that is able to sense material patterns and tie them together in a unified awareness of self. Such an idea was introduced by René Descartes in the 17th century. According to Descartes, there are two kinds of substances, matter, or res extensa, and mind, or res cogitans. Matter has geometrical properties involving extension in space, and mind is characterized by thinking, feeling, and conscious awareness. Descartes proposed that the mind interacts with the body. Sense perception involves the transmission of information from the body to the mind, and willed action involves the transmission of information from the mind to the body. Descartes speculated that the center of mind-body interaction might be the pineal gland situated in the center of the head. Over the years, scientists and philosophers have been unable to make any progress in understanding how a non-physical mind might interact with the physical body. As a result, they have tended to reject this idea in preference for purely mechanical theories of the mind. However, theories of mind-body interaction continue to be proposed by scientists. In recent years, such ideas have been proposed by neuroscientists such as Wilder Penfield and Sir John Eccles, and by philosophers such as Karl Popper. One theory was jointly advanced by Popper and Eccles. This theory is quite complex, but in essence it involves the idea of a non-physical mind that interacts with arrays of neural modules in the cerebral cortex of the brain. This mind responds to high-order neural patterns. According to Eccles, the unity of conscious experience is provided by the self-conscious mind and not by the neural machinery of the liaison areas of the cerebral hemisphere. One objection to theories of mind-brain interaction is that injuries to the brain are known to impair specific mental functions. Therefore, the mind must be simply a product of brain function. This objection can be answered by considering that the mind may program the brain computer. A person using a computer may become dependent upon it, and he may be unable to carry out certain operations when the computer loses files due to a hard disk failure. Similarly, the mind may be unable to carry out certain functions if the brain is damaged. This problem will be particularly severe if the brain is no longer readily programmable due to changes caused by aging. Another objection to theories of mind-body interaction is that such interaction would seem to violate the laws of physics. Of course, one solution to this problem is to suppose, with Thomas Huxley, that the mind can sense the behavior of matter, but has no power to control this behavior. However, the physicist Eugene Wigner has pointed out that we have no example in physics of a phenomenon in which A influences B, but B has no influence on A. He argues that consciousness exists in addition to matter, and that since matter can influence consciousness, it must be that consciousness can also influence matter. He therefore proposes that the laws of physics will have to be revised to incorporate consciousness. Such a step may seem radical, but we should keep in mind that the 20th century has been marked by revolutions in physical theory that were completely unanticipated by physicists of the 19th century. For example, the theory of relativity introduced strange transformations of space and time, and quantum mechanics replaced material particles with waves propagating within a Hilbert space of infinitely many dimensions. To see how a theory of mind-brain interaction might be formulated, it is useful to examine the Sankhya philosophy of India. According to this philosophical system, a living being consists of three components: the gross material body, the subtle material body, and the Atma, or conscious self. According to the Sankhya philosophy, gross matter consists of a series of transformations of ether, or Akash, which is regarded as the substance of space. These transformations generate air, fire, water, and earth, which represent the sum total of the material elements as we know them. This theory is reminiscent of the theory of geometrodynamics based on general relativity, in which an attempt is made to represent all matter as patterns of deformation in the underlying metric of space-time. According to the Sankhya philosophy, the subtle body is made up of the elements called mind, intelligence, and false ego. These elements are material in the sense that they lack consciousness. They can be thought of as a kind of material energy that is more subtle than ether or space, and that can be molded, perhaps in a computer-like fashion, to represent ideas and patterns of thought. The energy of false ego is molded to represent the software for the false material self-identification of the conscious being. Beyond the false ego is the Atma, or the self proper, which is endowed with consciousness. We speak of the Atma as non-material, since we use the absence or presence of consciousness to distinguish between material and non-material entities. The interactive link between the Atma and the false ego is very subtle and is far removed from the domain of empirical science as we know it today. However, the link between the subtle mind and the gross physical brain may be amenable to scientific study. According to the Sankhya philosophy, the element of ether is the intermediate link between the gross body and the subtle mind. The mind generates wave patterns in the ether, which we may think of as the fabric of space. These patterns are amplified by material interactions, and they result in systematic changes in neural activity that enable the mind to direct brain activities. The neural activity of the brain also creates disturbances in the fabric of space, which influence the mind element and thereby allow for sense perception. It is perfectly possible for wave patterns to emerge from the subatomic background noise and coalesce to produce macroscopic organized patterns. Here we see a simple model of a medium that can propagate waves. This medium propagates waves according to the classical wave equation. If the proper input wave is introduced into this system, the result is the production of two organized patterns, first a letter A, and then the symbol Om. To produce organized patterns, the key requirement is for the initial disturbances to be properly organized. The disturbances can start at arbitrarily small magnitudes and be brought to a macroscopic magnitude by natural amplification processes. For example, here is a model in which elastically colliding disks represent molecules in a gas. We see disks of two colors colliding chaotically, starting with a random initial arrangement. Now let us go back to the initial arrangement and systematically change the directions of motion of the disks by amounts so small that they would be impossible to measure. Now the disks quickly form an organized pattern. This involves effects of exponential amplification that are studied in the theory of deterministic chaos. This shows that mind-body interactions may produce macroscopic effects without a need for measurable disturbances in the dynamics of brain molecules. These interactions should produce changes in the entropy and information content of the brain, however, since they involve the transmission of information from the mind to the brain. This brings us to our last topic, the question of whether or not there is any direct evidence for mind-brain interaction. The answer is that such evidence does exist. Some evidence for this comes from modern medical science. Physicians often encounter reports of out-of-body experiences. These typically occur during heart attacks, automobile accidents, and other traumatic events. Many people have reported observing their own body from a vantage point above it while being resuscitated from cardiac arrest. Dr. Michael Sabin, initially skeptical of such experiences, sought to confirm or discredit them. He requested heart attack patients reporting out-of-body experiences to give details of their exact medical treatment during the time their heart was stopped and their brain had no blood supply. In the group he studied, several people gave numerous explicit details of their own resuscitation that were confirmed by their medical histories. And no one made any serious mistakes in describing the resuscitation process. In contrast, in a control group of seasoned cardiac patients who did not report out-of-body experiences, no one correctly described details of his own resuscitation, and many made serious mistakes in describing the resuscitation procedure. Dr. Sabom considered many theories that have been offered by doctors and scientists as explanations of out-of-body experiences. After showing that these did not fit the facts, he tentatively concluded that separation of the perceiving self from the body had actually occurred. Sabom questioned, and we quote, "Could the mind, which splits apart from the physical brain, be, in essence, the soul, which continues to exist after the final bodily death, according to some religious doctrines? As I see it, this is the ultimate question that has been raised by reports of the near-death experiences." This leads us to the question of transmigration, the transferal of a conscious entity from one physical body to another at the time of death. Dr. Ian Stevenson, a psychiatrist at the University of Virginia, has extensively compiled reports indicating that people are able to remember previous lives. Stevenson studied reports by very young children, not under hypnosis, with neither the motive nor the ability to invent elaborate past life stories. In one case, a child named Shukla was born to a family in the village of Kampa in West Bengal in 1954. When Shukla first learned to speak, she claimed that she had previously been a married woman named Mana Chakravarti. This person had died in 1948 and had lived in a village 11 miles away. The child Shukla was able to spontaneously show the route to Mana Chakravarti's house, and she named various members of the Chakravarti family on site. She also showed a strong emotional attachment to this family and to the surviving husband of Mana Chakravarti. Stevenson and his colleagues conducted many interviews with persons involved in this case in an effort to eliminate the possibility of fraud, subconscious coaching, and other explanations involving normal channels of communication. Stevenson was able to give strong evidence ruling out these explanations in many cases in which an alleged previous personality was described in detail and clearly identified as having actually existed. As of 1988, Stevenson had tabulated 2,500 cases from around the world. 881 of these were thoroughly investigated, and Stevenson was able to verify the reported previous incarnation in 546 instances, about 62% of the total cases investigated. Such extensive evidence suggests that the human personality can function outside the physical body and even transmigrate from one body to another. This is consistent with Sabom's evidence for out-of-body experiences, and it adds support to the model of the conscious self as a non-physical entity that interacts with the physical body. Perhaps we have already downloaded into robot-like machines, but not in the way imagined in scenarios of artificial intelligence.